So in the previous video, I hope I covered clearly enough the idea that when you're evaluating an inverse trig expression, so when you're just evaluating one, you need to know principal values. So in other words, if somebody just asks you what's the inverse sine of, the square root of 3 over 2, you need to supply the principal value, right? But when we are solving equations that involve trig, you may need to know some of the non-principal values. So if they say, solve sine x equals the square root of 3 over 2, understand that these are similar problems, but they're different. In the one on the left, you're being asked to evaluate an expression, which means you need to give the principal value. In the one on the right, you're being asked to solve an equation, which means we need to give, more than just the principal values. And usually for a problem like that, they'll give you a domain to work with. They'll say something like, oh, give us all the values between 0 and 2 pi, for instance. So in this video, I want to focus on how you find the values that are not the principal values. And I'm actually going to break that into 3 categories. I'm going to talk about, arcsine and arccosecant, because those are sine-based. Then I'll talk about arccosine and arcsecant, because those are cosine-based. And then finally, I'll take a look at arctangent and arccotangent, because those ones are sort of tangent-based. So I'll have a separate slide for each of those. So first, if you want to find all the values for arcsine and arccosecant, so the sine-based inverse functions, I see it as there being 3 steps. So step 1, you'll find the principal value of the inverse trig function, right? And I'll sort of go through an example of this as we do it. So suppose we wanted to solve the sine of x is equal to 1/2. Right? So presumably we would start this problem by doing the inverse sine. We would have x equals the inverse sine of 1/2. And when I did that, I now need to start finding all the principal values. By the way, I'm going to say here that I want values between 0 and 2 pi. Right? So step 1 is to find the principal value of that inverse trig function. Right? So the principal value of the sine of 1/2, so we sort of think about our unit circle, a y value of 1/2, happens over here at pi over 6. Great, so step 1 in my problem is that the principal value is pi over 6. Okay. Now step 2, I want us to find what I'm going to call the secondary value of the inverse trig function. And there's 2 ways to do that. One of them is by looking at the diagram over here on the right. If it happened there, it's also going to happen over here. And so in some sense, I recognize that that's 5 pi over 6. But some of you may sort of appreciate having a formulaic method for that as well. Because of the symmetry here, whatever we have here, I'll find one over here by doing, pi minus pi over 6. Like take pi minus your principal value. So I'm going to call that the secondary value. My secondary value is 5 pi over 6. Okay. So then in step 3 is where we find as many other values as we need. This now says add multiples of 2 pi or 360 as many times as needed. Because remember, you've got pi over 6, but we could also go around the circle as many more times as we wanted, right? So if I added, 2 pi to this, I'd end up with 13 pi over 6. And then if I did it again, I'd end up with, 25 pi over 6. For the other one, if I were to add that, I'd end up with 17 pi over 6, and then 29 pi over 6. And I could sort of keep doing this as long as I wanted to. In fact, in both directions, you could even, subtract 2 pi from these to find other ones. But this problem, they only wanted me to find values between 0 and 2 pi, so these are my answers. Like, in some sense, that's what that entire process looks like, right? So, step 1, find the principal value. Step 2, find the secondary value by subtracting from pi or subtracting from 180, that finds you the other one. Then add 2 pi as many times as you need to find all of the other values. So that's how you do it for arcsine and arccosecant. So I'm hoping I can do the next 2 slides a little bit more quickly. The next one I'm going to be talking about arccosine and arcsecant. Right, so same deal. Let's start by writing down a problem we're going to deal with. Suppose we wanted to solve the cosine of theta is equal to negative square root of 2 over 2. So step 1, we want to find the principal value. Well, for the principal value, I want to have an x value that's negative square root of 2 over 2. So let's see here, that's going to happen up here, and that angle is 3 pi over 4. Okay. So then I'm supposed to find the secondary value, right? Now again, you could do that by sort of going down this way and finding out what that angle is, but it's also good to know that in some sense formulaically, we can always find that other value by simply doing the opposite of the one that you already have. And the idea is, if this angle is positive 3 pi over 4, then this angle is negative 3 pi over 4. Now you might be thinking, well, isn't it 5 pi over 4? Sure it is, but I'll get to that in a second. Right? So that was step 1, then step 2. Step 3 is now that we're supposed to, just like we did last time, add multiples of 2 pi or 360 as many times as you need to. So if I were to add 2 pi to the top one, 2 pi is 8 pi over 4, so that would be 11 pi over 4. I could do it again and get 19 pi over 4, dot, dot, dot. For this one down here, if I add 8 pi over 4, I end up with 5 pi over 4, which was that sort of other direction that we talked about. If I do it again, I end up with, let's see, is that 13 pi over 4? And I forgot to do it again. Suppose that for this problem I told you that, again, I wanted values between 0 and 2 pi. Now that I've sort of made the beginning of a list of everything, I can identify that my answers are 3 pi over 4 and 5 pi over 4. That those would be the solutions to that equation. Right? So a similar process to the sine and cosecant one. The difference is that in this case you find the secondary value by taking the opposite instead of subtracting from 180. So in this one, in the last one of these, we're going to talk about how we do this for arctangent and arccotangent. And this one is admittedly quite a bit different. There are only 2 steps. Step 1, you find the principal value. Step 2, you just add multiples of pi or 180. I'm going to do an example of this so that we can see it. I'll start with a fairly easy example, one that hopefully we'll know pretty well. Let's say you were asked to solve the tangent of x equals 1 on the interval from 0 to 4 pi. Right? So step 1 is we're supposed to find the principal value. So I would go to my unit circle, and I'd sort of think, like, where would I find a sine x over cosine x of 1? Well, that would happen whenever sine and cosine are equal to one another. So that's basically going to happen right here at pi over 4. But if you think about it, it will also happen, like in some sense, the other place where sine and cosine are equal to one another is down here. Notice that that's sort of exactly 180 degrees or pi radians away. And so that's why when you're working with arctangent and arccotangent, all you have to do is find your principal value, pi over 4, and then simply start adding pi to it to get this one, then the next one, then the next one, then the next one, and so on. Right? So if I add pi to this, that's 4 pi over 4. I'll end up with 5 pi over 4, and then 9 pi over 4, and then 13 pi over 4. The next one after that, I don't need a comma there. The next one after that would be 17 pi over 4. But 17 pi over 4 is larger than pi over 4, so I don't need that one. This equation, it turns out, has 4 solutions on the interval that was given. And that's what it is. So here I have a problem that I wanted to give you a chance to work out on your own. So pause the video, work through this one, and figure out what all the solutions may be, and then we'll check them together. So let's see, this problem effectively amounts to finding the inverse sine of negative a half. So if I think about my unit circle, I will find a y value of negative a half here. That's sort of, one of the shorter values there. So this thing here is negative pi over 6. So that means my principal value for this problem is negative pi over 6. From there, I'll find my secondary value. Again, 2 options for doing this. One of them is to see it here. The other is to simply do pi minus negative pi over 6. That gives me 7 pi over 6. So I have 7 pi over 6 for that one. Okay. After that, I'm supposed to go through and add multiples of 2 pi to these things. Well, 2 pi is 12 pi over 6, so that would give me 11 pi over 6 here, and then 23 pi over 6 here. For this one down here, if I add 12 pi over 6, I'll end up with 19 pi over 6. And then after that, I would end up with 31 pi over 6. We may want to notice I could even go backward on this one. I could end up with negative 5 pi over 6 as well. In some sense, you've got infinitely many values here going, greater than and less than all of these things. So now, which of these values are on this interval? Well, you've got 11 pi over 6, you've got 23 pi over 6, which is almost 24 pi over 6. So if we had found the next one over here, it wouldn't have counted. We've got 7 pi over 6, we've got 19 pi over 6, this is too big, this is negative. So those 4 values are the 4 solutions to this equation on that interval. So my last example here is actually a calculator problem, and something incredibly important for you guys to know about the calculator, and I wish I'd mentioned it earlier in the video, is that your calculator always finds principal values. That's all your calculator will ever give you is principal values. Alright, so if you tried to solve this problem in your calculator by going n equals the inverse tangent of, not 0, of negative 3.714, you punch that into your calculator, you will end up with negative 74.930 degrees. So okay, cool. That was the principal value. Note that the principal value that I found was not on the interval that they asked for. And that's fine. That just means that for the sake of this solving problem, nobody cares about the principal value. I care about values between 0 and 360. Right? So my calculator gave me the principal value. Now that I have that principal value, remember what we do to find other values of tangent. We're supposed to just add 180 or pi as many times as we need to. So if I add 180 once, I'll end up with 105.070 degrees. 070. If I add 180 again, I'll end up with 285.070 degrees. Technically, if I did it again, I'd end up with 465.070 degrees, but we only wanted values between 0 and 360, so I actually didn't need the principal. I needed the principal value to find them, but that's not one of my answers. These are my 2 answers, because the other one beyond that is too large. So this business of finding non-principal values is arguably most important when you're working with a calculator, because your calculator, it doesn't do the unit circle. It just finds a principal value and reports it. So it's important that you guys know, 1, what the principal value is, and then 2, how to find the other values once you've been given the principal value.